All right, welcome back. We're from vacation, I guess. We are going to solve exponential equations again. So this is like the algebraic piece of exponentials. We've looked at graphs of them, remembering that they kind of shoot up like this. We've also looked at some word problems for growth and decay, and now we're going to solve these equations. And the key is that this base, this number here on both sides, has to be the same, and you can only have one of them. So this has two 2's over here, even though it's the same as this. I need it to only be a single 2 over here and a single 2 over here, and if that's the case, then I can set my exponents equal to each other. So each of these problems today is going to be slightly different than each other, but it's different, slightly also more advanced than what we saw last week before break. So the first thing I need to do over here is if I have the same base and I'm multiplying, then I am allowed to add my exponents. So this is supposed to be a big plus sign. So what I can do on this problem is on the right side, I can add 5 plus 2 and get 2 to the 7th. The left side, I'm not going to do anything to because I've already got that 2. So again, sometimes it's easy to identify your base you want to use because it's right in front of you. Sometimes it's not. But your job is once you have a 2, the same base on both sides, and that base is only showing up once, your job with exponential bases is done. Now you can just set the top exponents equal to each other. So it's basically this is 2 to some power has to equal 2 to 7, which means this power has to also be 7. So I can quickly rewrite this problem and just deal with this part of it. Equals 7. I add 6 to both sides and I get 13 and I'm done. So you're going to pause the video. You're going to try this one on your own, and then I'm going to reveal the answer for you. So pause it, try it. All right. Unpaused. Here's your answer. Again, these 2's can be combined to an 11, and then you set your exponents equal to each other, and you have a quick equation to solve. Nothing too fancy on that. You're just using some of those properties of exponents we saw earlier. All right, so we're going to move on to what may be the trickiest one on here, and that's because when I look at 4 and 8, 8 is not a power of 4. 4 is not a power of 8. So I'm in a situation where I have to figure out what base I can use and rewrite both 4 and 8 using that base. So these numbers are pretty small and somewhat friendly, so I know that 4 is 2 squared. So I can rewrite this as 2 squared. And I need to remember that outside of that, there is still this x plus 1. So that didn't go away. And I have to write the other side now with a base of 2, and 8 is the same as 2 cubed. So notice how I have a 2 on the left as a base, a 2 on the right as a base. So I had to figure that out because I couldn't solve this otherwise. We'll have other techniques later, but for now, if I can't write the left and the right side as powers of the same base, I can't do this problem. Now I want to simplify this. This is our power to a power property, which means I can multiply 2 times x plus 1, and that means I have to distribute. I can't just multiply the 2 times the x. This 2 has to hit both of these. So the left side will become 2 to the 2x plus 2 equals 2 cubed. And once I'm there, I've got the base on the same side on the left as I have on the right, and there's only 1 2 on the base over here. There's only 1 2. That means this 2x plus 2 has to equal 3. So that's our goal, is to get these bases the same. They don't always have to be 2's. It could be any number, but as long as it's the same on the left and the right, then I can set the exponents equal to each other. I subtract that 2 from both sides. I get 2x equals 1, and I divide by 2, and I get x equals half. Boom, done. And that means if I plugged a half up here and then multiplied that by 2, it would be the same as 2 cubed. And you can always go back and check that as well if you want. All right, you're going to try one again. Notice 9 and 27 are not powers of each other. I can't write 27 as a power of 9, and I can't write 9 as a power of 27. So you got to first figure out what that base is going to be. Pause the video, try this. Okay, video's unpaused. You should have gotten the base of 3. 9 is the same as 3 squared. 27 is the same as 3 cubed. And I have to keep this 2x minus 5 up there. And then again, the power to a power means this square here on the 3 can be multiplied by both of these. That's how I got 4x minus 10. And once you get to that point, then you just have your regular equation, I guess, and you go for it. All right, moving on to example 3. This one, 3 and 9. Again, this is 1/9, but I'm not going to let that freak me out because what I see is a 3 and a 9, and I know that 9 is a power of 3. So what I can do is the left side, I'm not going to actually do anything to. I'm just going to leave it as 3 to the 2x minus 4. But the right side, I need to write at 1/9 as a power of 3. So first off, 1/9, I already said 9 is 3 squared. Boom, that's 3 squared. But it's in the bottom. So if I have a fraction and the base I need is in the bottom, I have to turn it into a negative exponent. So 1/9 is the same as 1 over 3 squared, and 1 over 3 squared is the same as 3 to the negative 2. So this is where our negative exponents come back from the beginning of the year, and we've done some work with those. But that's the trick with the fraction. You got to flip it, and then you have a negative exponent, and that's not a big deal, but because I have 3 and 3. And if I had this as 1 over 3 squared like this, it doesn't work because that is not the same as 3. So I've got to flip it and make a negative power. Then I can set the tops equal. 2x minus 4 equals negative 2. Add 4 to both sides. If I add 4 over here, I'll get 2. Divide by 2, I get an answer of 1. And once again, you are going to try that with this one. Again, notice you got a fraction, so you're going to practice that skill of making a negative exponent out of it and then solving. So pause it, try it. All right, here is your answer. Scroll up so you can see it better. Again, 16 is 4 squared, so I was able to rewrite that as 4 squared, power to a power. Same rule we did in the first couple examples. And then 1/4 is 4 to the negative 1, so you need a negative 1 there. And then you can solve your equation. Now, if somebody saw these as powers of 2, you would have gotten the same answer. This would have been 2 squared, so this would be 2 to the negative 2, and this would have been 2 to the 4th, so you would have still solved it and gotten the same answer. All right, we only have a couple more to go, I promise you. All right, here we go. 4 squared equals 4x squared plus x. So you'll notice on this one, you might say to yourself, haha, I've already got a common base of 4 and 4, so I'm good to go. I am good to go. You should say that. And so you would write, 2 equals x squared plus x, because that's what we've been trained to do on the first 6 problems. The bases are the same. You just set those tops equal and go. And then you might say to yourself, maybe this wasn't such a nice problem because I have x squared, but we did a whole unit on quadratics. So I have to solve the quadratic. We have many ways to do it. Quadratic formula, factoring, etc. But the key with a quadratic, unlike the first 6, is I need to get 0 on one side and the whole quadratic in standard form on the other side. So I am going to subtract 2. I'm going to bring that over here. Then I got to factor this thing. Oops, that's going to be an equal sign. Some of you may use quadratic formula, but I know 2 is prime, so this has to be a 2 and a 1. Has to multiply to a negative 2, so these signs have to be opposite, but they have to add to a positive 1, so I would have to have a plus 2 and a minus 1, and that would give me all of the information I needed, and so my answers are 1 and negative 2, and 2 answers would work up here. So there you go. You're going to try one. I'm going to move this down a little bit so you can see it. Again, this one, notice that you already have the same base, so pause this video and try it. You got a squared up here, so you're going to have to do a little bit of a quadratic action. Pause it, try it. All right, here you go. Here is your answer. Bases are the same, you set them equal. I moved all of this stuff to the right because I hate a negative x squared. So I added x squared, there it is, and I subtracted 1. And when I subtracted 1 from that, it became 1. I put it in standard form. I factored it. In this case, it's a square binomial, so x equals 1. All right, one more to go, and then that's it. You're good to go. You're going to practice these things. Again, I told you there's a lot of different levels here. So this one is 4 and 8. Again, I've got to realize that I think we've already saw this. That means I have to use a base of 2, but I've also got this annoying square root in here, so we're going to deal with that as well. But the first thing I'm going to do is I'm going to rewrite these as powers of the same base. So 4 becomes 2 squared. And I'm going to use parentheses so you can kind of see where things are coming from here. So that has a power of x outside of it. I'm going to leave the square root alone at first. So I'm going to have this big old square root. I'm going to deal with the rest of it to begin with. So 8 is 2 cubed, so I'm going to write that as 2 cubed. And it has a power of 4x minus 2, so I can put that outside of it. So 4x minus 2. And I'm going to deal with this square root in a second. The first thing I'm going to do is this power to a power, and I'm going to deal with this power to a power. So the left side will become 2 to the 2x. That is a horrible looking 2, but that is a 2. Equals, and again, I'm going to keep this big square root right here for a second. And I have to take this 3 and I have to multiply it by this power, so I have to distribute it. So the right side will become 2 to the 12x minus 6. All right, so 3 times 4x minus 2, 12x minus 6. Now I'm going to deal with the square root, and I'm going to deal with it by erasing it. And obviously on yours, you don't have to erase it. You can just move to the next step. But a square root is the same as a power of 1/2. So I'm going to rewrite that square root as a power of 1/2. And now this power can be raised to this power. So the left side is 2 to the 2x equals, and this 1/2 gets multiplied by 12x minus 6. The same thing we did here. Power to a power, I multiply. So 12x minus 6 times 1/2, I have to take half of both of those. So I'm going to get 6x minus 3. And after all of that work, notice that I've got my 2 and 2 finally isolated. This is a long problem. There's a lot of stuff going on here. And I can come off to the side and go 2x equals 6x minus 3. And now I can solve this regular style. No more concerns about any of this other stuff. I subtract 6x from both sides, would give me a negative 4x over here. And if I divide by negative 4, I get an answer of negative 3 over 4, or 3 over negative 4. That's the same thing. So your answer isn't really nice and clean, but that is what you could plug in up here. And when you calculated this side and you put it over here, and you took that square root into consideration, it would equal each other. So you're going to try one. Notice you've got a square root over here on the top. So pause the video and deal with this square root, realizing it probably the third step is when I turned it into a 1/2 power. So you got to deal with that square root as a 1/2 power. Pause the video, try it. All right, there is your answer. Again, I turned 64 and 16 into powers of 4. You could have also turned them into powers of 2. I did this power to a power first. So 64 is 4 cubed to the 3x. Power to a power gives me 4 to the 9x. And then I took this square root and I made it a half. And 9x times a half is 9x over 2, or 9/2 x. Then I had my bases the same, and I set those equal to each other, and I solved it. And I noticed that I have a wrong answer here. So I will erase this, and I will write the correct answer, which I now have more room to write it anyway. So if I multiply the 2 over, I get 4, and then I divide both sides by 9, my answer would be 4/9. And sometimes my 4s and 9s look the same, so I'm being careful. All right, there you go. Hope you enjoyed that, and you are now going to practice some of this. Thank you.